Complete the following warm-up. As you finish a problem, you can resume the video and check your answers. Number 1. Answers are x equals 9 square root of 2 and y equals 9. Number 2. X equals 3.75 radical 3, or x is 15 radical 3 over 4. Number 3. The altitude of an equilateral triangle is 12 centimeters. Find the perimeter. In this particular problem, I've drawn the picture of the equilateral triangle. Notice that all angles are 60 degrees. However, the altitude bisects the vertex as well as bisecting the base. So you have a 30, 60, 90 triangle. If the height is 12, that is the longer leg. To work backwards to the shorter leg, you're going to divide by radical 3, which gives you 4 radical 3. And then the hypotenuse is twice the short leg, which is 8 radical 3. All three sides are 8 radical 3. The total would be 24 radical 3 inches. Number 4. The diagonal of a square is 12 inches. Find the area. If the diagonal is 12, you can work backwards to the sides of the square. Each triangle in this picture is a 45, 45, 90. To work backwards to a leg, simply take 12 divided by square root of 2, which is 6 square root of 2. The area is going to be 6 square root of 2 times 6 square root of 2, which gives me 72 inches squared. Number 5. The perimeter of a rectangle is 32 feet. The length is 3 times as long as the width. Find the length of the diagonal. So in this picture, you can see that I've labeled the sides using a variable of x. The width being x, the length is 3 times that amount, which is 3x. So you're asked to calculate the length of the diagonal. So in this particular problem, you can see that you have all 4 sides being x, its opposite x, and then we have up on the top would be 3x and 3x, for a total of 8x for the distance around. So what that tells me is that the value of x has to be 4. So we have a short leg of 4, a longer leg of 12, and then the unknown hypotenuse. You're going to go ahead and find c using Pythagorean theorem, and you get 4 radical 10. And that's in feet. Number 6, the perimeter of an equilateral triangle is 48. Find the altitude. All 3 sides would be 16. The altitude bisects the base. Across from the short angle, or the smallest angle, is the short leg, which is a side of 8. And for this problem, we also know that the longer side would be 8 radical 3, because it is the short side times the square root of 3. And that's for the longer leg. This section talks about trigonometry, which is the math of angles and sides of triangles. This is section 8.5, and it's called Tangent Exploration. Trigonometric ratio. It's a relationship between the sides and angles of a right triangle. In other words, if you know 2 sides of a right triangle, you can find an angle that's contained within the triangle. And the opposite is true, that if you know an angle and you know one of the sides, you can also find another side of it. So in this first picture, which side is the hypotenuse? And that would be AC. The side that's opposite from angle A, if I trace that over, would be side BC. Which side is adjacent to A? Now the adjacent sides, it kind of looks as if there's 2. However, we don't include the hypotenuse being named as adjacent for the purposes of the trigonometry. So the side that's adjacent to A is going to be AB. Which side is opposite of C? So tracing from the angle to the opposite side is also side AB. Which side is adjacent to angle C? Once again, we're not going to consider the hypotenuse as being adjacent for this particular problem. We're only going to use the side that creates the angle, or the vertex at angle C. The sides AC would be BC. In triangle GEO, describe the relationship of the following sides to angle G and angle E. Fill in the table with the words opposite, adjacent, or hypotenuse. Do this on your own, pause the video, and when you finish this table, go ahead and open it up to check your answers. Comparing to angle G, OG is adjacent to angle G, EO is opposite, and EG is the hypotenuse in relationship to angle G. In comparison to angle E, OG is opposite, EO is adjacent, and EG is the hypotenuse. We're going to do the same thing here for number 3. We're going to fill in according to values that are given, as well as variables. So we have angle D. The opposite side of angle D is EF, and the length of that opposite side is 41. The adjacent side to EF is DE, and the length of that adjacent side is 15. For angle F, the opposite side is DE, the length of that opposite side is 15. The adjacent side is EF, and the length of that adjacent side is 41. Why is angle E left out of the table above? Pause the video, think about it, and then I'll show you the answer. Angle E is left out of the table because it has two adjacent sides, and the opposite is the hypotenuse. When we use the words opposite and adjacent in trigonometry, we're not referring to the hypotenuse at all. The first trigonometric ratio we're going to talk about is called the tangent ratio. It's a specific ratio between two side lengths. So if I take any angle A and I take the tangent of it, that is going to be the length of the leg that's opposite of the angle divided by the length that's adjacent to that specific angle. In fact, we use an abbreviation for this of TOA, where T stands for tangent, O stands for opposite, and A stands for adjacent. Any angle is created from the ratio of these two legs in terms of tangent. So tangent of any angle A is going to be the opposite side divided by the adjacent side. So let's go ahead and do some calculations. Using the above triangles, write out the segments used in your ratio, the side length measures, then use a calculator to compute the ratio. Round to the nearest hundredth. So we're looking at tangent D of angle D. So we're using opposite over adjacent. So the opposite would be your 41, and then the adjacent would be your D to E. So we have that the tangent of D is going to be EF over DE, which is going to be 41 over 15, which gives me a ratio of 2.73. 2.73. Now that's not the actual size of the angle itself, it's the ratio that is represented by angle D using the opposite and the adjacent sides. Let's go on and do tangent of F. The tangent of F would be DE over EF, which is 15 over 41. It gives you 0.37. Moving on to this next picture, tangent of K, opposite over adjacent, is JL over KL, 63 over 23.1, which gives you 2.73. Angle J, the tangent of J, is KL over JL, which is 23.1 over 63, which is 0.37. Notice the values in the first picture and the second picture have the same ratios. Make a conjecture about tangent ratios. What do you notice? If the ratios equal the same decimals, what can you assume about the angles, and what can you assume about these triangles? Well, let's talk about three different things. The first one, The tangent ratios in a triangle are reciprocals of each other. If you go back to the bottom of the other page, you can see that tangent D and tangent F from number 4 are flipped over from each other. Additionally, the same ratios indicate that the angles are going to be congruent. Now, in this picture, remember from earlier problems we've done, if you have proportionality, you've got similar triangles. What you have in similar triangles are congruent corresponding angles. So that's how we can derive this idea that the same ratios mean the angles are congruent. The triangles have to be similar because of the fact that the ratios are proportional. You can use your calculator to find the tangent of any angle, but first you have to set your mode to degree. So in your calculator, and you'll look at your scientific calculator, you're going to find the mode button, which is up towards the top next to the blue button, and you're going to click on it, and the third row down you'll see radian and degree. By default, a graphing calculator is set to radians. You have to set yours to degree to be able to figure out the missing angle. So once you have it set to degree, we're going to go through and do the ratios. So let's look at 6a. A 19-degree angle will have a ratio of its sides of 0.34. So in order to type that into your calculator, you're going to hit the tangent button. And what you will see on your calculator when you pull this up, if you enlarge this, you can see that the word tangent is 2 steps above the number 9. In fact, it's right above the parenthesis. So you'll hit the tan button and then the 19 and then hit equals. You should get 0.34. Type in the tangent of 20 and you should get 0.36. Notice the angle is getting bigger and so is the tangent ratio. Tangent of 21 is 0.38. The tangent of 68 degrees is 2.48, even bigger. The tangent of 69 degrees is 2.61. And the tangent of 70 is 2.75. Make a conjecture to fill in the following angle measures. So let's go back to angle K in our picture. Angle K had a ratio of 2.73. Where would 2.73 fall within these values that you see over here in D, E, and F? Somewhere between E and F, or between 2.61 and 2.75. So about 69.5 degrees. Angle J. Going back to the other page, angle J is a 0.37. So when I look at the ratios, 0.37 falls somewhere between 0.36 and 0.38, about halfway in between. So angle J is about 20.5 degrees. Angle D and angle F, if you go back, match up with angle K and angle J. So angle D is also 69.5 and angle F is 20.5. All right. Number 7, now draw a 45, 45, 90 triangle. What is the tangent of 45 degrees? So when I look at the scale factor drawing for a 45, 45, 90 degree triangle, if I look at a 45 degree angle inside of it, the opposite over the adjacent is 1 over 1. So the tangent of 45 is 1. And why would this always be true? The legs are always congruent in a 45, 45 degree triangle, so the ratio would always be 1. Now put 45, or the tangent of 45 degrees in your calculator, and what do you get? You should get the same answer as number 7. You should get a tangent of 45 equals 1. How does the ratio change as the angle measured becomes larger, and why? The tangent ratio increases. As an angle gets larger, the side opposite increases and the side that's adjacent decreases. The ratio of opposite over adjacent increases as well. Exercises. To do some practice, please do each problem, pause the video, and then come back and check your answers. Number 1, the tangent of A is 4/3, which is approximately 1.33. The tangent of B, 3/4, or 0.75. Number 2, the tangent of angle A in lowest terms is 12/5, or 2.4. And the tangent of B is 5/12, or approximately 0.42. The tangent ratio is also used to calculate unknown side lengths and unknown angles in right triangles. We can use the tangent ratio to find the unknown side lengths in these right triangles. We can say that the tangent of any angle is equal to the opposite over the adjacent. So you have 3 parts of this equation, and you can solve for any one of them if you know 2 of them. We can also find missing angles, and in order to find the missing angle, you have to use what is called tan inverse. So what I do in this problem, if I want to take tan x and I want to solve for x, if you view x as trying to be by itself, you'd have to get rid of the word tangent. But here's the catch. That is not multiplication, so you can't get rid of the word tangent with division. What you have to do is multiply by the inverse operation. So what we do is we type tan inverse on both sides of this problem. If you do it to one side, in fact, we'll parenthesize this and show it as multiplication. So if you do it to one side, you must do it to the other. Now in this particular problem, in order to do that, you'll have to put the tan inverse in front of the opposite over the adjacent. So you're multiplying both sides by tan inverse. Now on the left-hand side of this, the tan and the tan inverse cancel out. So what we have left is that the angle x is by itself, and x is equal to the tan inverse of the opposite over adjacent. Now that does seem confusing, but that's merely a calculation on your calculator. We'll show that in a minute. So number 3, use the tangent ratio to find the unknown side length. So in this problem, I know an angle, and I know the side opposite of it, but I don't know the side that's adjacent. So I'm going to set this up that the tangent of 40 is equal to 3 over x. In this problem, I'm going to solve for x. So what I'm going to do is cross multiplication. I can put a 1 underneath my tan 40. And so I have x times tan 40 equals 3 times 1. Now to get x by itself here, you are going to divide both sides by tangent of 40 degrees. So you do the same thing over here. Now we don't have to use tan inverse because we're getting rid of the entire angle and the tangent altogether. The angle in this case is not missing, it's a side. So over on the right-hand side, the tangents cancel out completely, and that's why you have 3 over tan 40. So putting this into your calculator, you're going to get approximately 3.58. So the length of letter x or side x here is about 3.58. Number 4, the 12-degree angle. So you're going to write tangent of 12. The opposite is x, and the adjacent is 2.5. Put a 1 underneath your tangent of 12 and cross multiply. You're going to get x equals 2.5 times the tangent of 12, which is about 0.53. So it's a very short side. Use the tangent ratio to find angles A, C, D, and F. In order to isolate the angle, use tan inverse. So let me go back to the calculator picture for just a minute. I'm going to copy paste this onto that page so we can see it. So for tan inverse, if you look at your calculator, locate the tan button, and above it in blue is the word tan inverse. So when you're using tan inverse, just hit the second button and tangent. And you can do that calculation very easily. Alright, so let's go ahead and do this. So we have, using the tangent ratio, find angles A, C, D, and F. In order to isolate the angle, use tan inverse. So I want to figure out what angle A is in terms of size. Angle A, in terms of its tangency, is the ratio of its opposite over adjacent. So that's going to be 4 over 3. To isolate the angle A, I'm going to multiply both sides by tan inverse. Rather than showing it both sides every time, I'm just going to put tan inverse over on the right side, like I did on the first problem that I was explaining it. You enter this directly into your calculator, so you'll hit second, tangent, and then parenthesis 4 divided by 3. And that will give you the angle size. It's approximately 53.13 degrees. And the next one, angle C. Angle C's opposite over adjacent is 3 over 4. So to find angle C, tan inverse is 36.87. See if you can make a pattern or conjecture about angle A and angle C. What you notice is that these two add up to 90 degrees. So I didn't necessarily have to go through this process of finding angle C. I could have taken 90 minus angle A to get it. Number 6, pause the video, work them out yourself, and see if you can figure them out. Tangent of D is 12 over 5. So D is the tan inverse of 12 over 5, which is 67.38 degrees. The tangent of F, which is 5 over 12. So F is tan inverse of 5 over 12, which is 22.62 degrees. All right. Extra practice problems here. Find A and B. Drawing may not be to scale. So for this particular problem, we have, it doesn't look like it, but in the large picture you have an isosceles triangle. So that means that both base angles are congruent. So that might come in handy. So we'll put a 42-degree angle in there. So now in this picture, are you going to have enough information that you could find A and B? In this case, B has to be 60. And let's see why. Well, B is going to be very straightforward. When you have a triangle that's isosceles, then you have an altitude that bisects the base. So these are both congruent, so each of those sides have to be 60s. So we have 60, and we have another 60 over here. To find the A, which is the altitude, you're going to use trigonometry. You're going to use the ratio for tangent. So the tangent of 42 degrees is going to be A over 60. Put a 1 underneath your tan 42 and cross multiply. A is going to be whatever 60 tan 42 is. Put it into your calculator and you get 54.02 degrees. Or sorry, that's height. Alright, number 8. Find A and B. Drawing may not be to scale. Now in this particular problem, you have a 45, 45, 90 degree triangle over here, and the larger picture is a 30, 60, 90. 30 here, 60 here, and 90. You can do this problem either with the shortcuts that you know for 45, 45, 90s and 30, 60, 90s, or you can do trigonometry. So if you use shortcuts, side A will be 160 because of a 45, 45, 90, the legs are identical. Additionally, from the larger picture, The shortest side in the large triangle is 160, so the long leg is going to be 160 times the square root of 3. That means the sum of a and b together has to be 160 square root of 3. If a is 160, you could subtract from both sides and get b is 117.3. Now, if you choose to use trigonometry, you can also do this problem. For the first part, when I look at the 45-degree angle, the tangent relationship is opposite over adjacent, which is 160 over a. Cross multiply, you'll get a is 160 tan 45, which gives you the 160. For the larger picture, if you wanted to use the tangent ratio, tangent of 30 is the opposite, which is 160, over the sum of a plus b. In this problem, if we do cross multiplication and isolate the a plus b, we end up with 160 over tan 30. If you simplify that right-hand side, the sum is approximately 277.13, but we already know that a is 160, so you just subtract it from both sides, and you get the 117.3. So it works out the same. The homework for this section is page 308, numbers 1 through 18.